In question 5A, you're told to write down a geometrical result that can be used to construct a tangent to a circle at a point. It's important to note that they're asking for a geometrical result. I'm not entirely sure what they consider to be a geometrical result, but I would imagine anything that comes from trigonometry or coordinate geometry probably won't get you full marks. So, for example, talking about the sine of the angle between them probably won't help you much. Saying that the slope of the tangent is the inverse negative of the slope of the radius at the same point might not get you full marks either, so just stick with geometry just to be absolutely sure that you get the marks. This is what I have then, that the tangent to the circle is perpendicular to the radius, or is at 90 degrees to the radius either. You could potentially also say that the tangent touches the circle at exactly one point, but I don't see how that would actually help to construct the tangent. So I'm not sure again if it will get you the whole marks for the question. In part 2 you're given a circle with 2 points, one where C is the centre and A is just a point on the circumference. I've also drawn in the radius, the line between these 2 points, and your question is to construct the tangent to the circle at this point A. Remember then that the tangent at this point is going to be perpendicular to the radius at that point. So what they're asking you to do really is construct a line that is perpendicular to the radius at this point A. Think about what perpendicular means then. See if you can figure out how to draw that perpendicular angle. They don't explicitly say not to use protractors or set squares or anything like that, but you should be able to do it with just a compass and straight edge. So that's the way I'm going to show you how to do it now. What I'm going to do then is bisect the angle at A. Since we only have one line coming out of A at the moment, we'd be bisecting full rotation, which isn't going to help. We'll just get 180 degrees. So what I'm going to do first of all is to extend this line CA so that it continues on, and that way there'll be a 180 degree angle at A. Now that I have a 180 degree angle at A, if I bisect that I'm going to get 90 degrees, in other words perpendicular. So first of all, with A as being my vertex, I'm going to mark off 2 points that are equidistant. I'm going to use C as 1 point because I've already got that point, and I'm going to find the point that's equidistant from A on the other side. So that's the distance CA. Flip that over, and that there is a new point. I'm not even going to bother giving it a name. Now I draw 2 more arcs of the same length, so I set my compass to whatever length I like as long as it's longer than the length CA. I'm going to set my compass at this new point and draw an arc just here. I'm going to draw an arc of the same size from C, like that. With this new point here then, the line between that and my vertex A, that's going to be 90 degrees to this line here, C to this point. So if I draw this line in, then that's going to give me a tangent to the circle at A. And there it is, the line now goes through those 2 points, and since I've bisected this line here at the point A, I know that my new line is at 90 degrees to the radius. And just given the definition of the tangent, I know then that this new line is the tangent to the circle at A. In part B you're given a triangle and you're asked to construct the circumcenter and the circumcircle of the triangle using only a straight edge and compass. If you can't remember which one the circumcenter is or the circumcircle is, just maybe draw all of them: the circumcenter, incenter, orthocenter, and the centroid center. The circumcircle I just remember as being the one that goes all the way around, because I just remember circumnavigating the globe is to go all the way around the globe. So the circumcircle of the triangle is the one that goes all the way around the triangle and only touches it at the 3 corners, the 3 vertices of the triangle. The circumcenter is constructed by bisecting all of the sides of the triangle. So to do that, you set your compass at the corners, at the vertices, draw arcs like that, set it at the other vertex and draw the same arc, It has to be the same length. And join the 2 points where those arcs cross, and you will have bisected one of those sides. What has just been constructed really is the so-called locus of points that are all equidistant from those 2 vertices. So if I take any point on this line here, I know that that point is the same distance away from this vertex and this vertex. So any circle that I construct there is going to pass through those 2 points. If you construct this bisector for at least one other side, then what you're going to find is a single point that is equidistant from all 3 of those vertices. Now I've constructed another bisector, so I know that any of the points on this new line here is the same distance away from this vertex as it is from this vertex. So if I take this point here where those 2 bisectors intersect, then I know that that point there is going to be equidistant from all 3 of those vertices. In other words, what I can do is draw a circle that touches exactly all 3 of those vertices. In other words, that's the circumcircle. Here's the circumcircle then. Excuse the quality of the drawing. It touches exactly all 3 of these vertices at just exactly the 1 point. This is the center of the circumcircle, or the circumcenter. So if I draw, say, a line between any of these vertices and the center, all those lines are going to be the same length, which is the radius of the circumcircle. To construct this, I could have also bisected this bottom line here. It would have just gotten me the exact same point because there's only one circumcircle.